So we're going to start with a joke. A neutron walks into a restaurant and orders a couple of Cokes. As she is about to leave, she asks the waiter how much she owes. The waiter replies, "For you, no charge." Get it? Neutron doesn't have a charge in the nucleus. No charge. So funny. Okay. So we're on the last page of our chemistry review, and we're going to talk just a little bit about OChem. And basically it says students know that large molecules, polymers, and we're going to start by writing that. So proteins are an example of a polymer. Let's get this out of the way. So proteins are an example of a polymer, and proteins are basically long strands of carbon and hydrogen. So we're going to write CH3 dash CH2 dash CH2 dash CH2 dash CH2 dash, we'll say CH2 again, and then CH3. Okay, so this is what is known as a polymer. And basically they want you to know that they are combinations of simple subunits. These guys here are your subunits. And organic chemistry basically just has to do with anything dealing with carbon. It's typically carbon and a hydrogen or a nitrogen or an oxygen or a fluorine. Notice these are all covalent. And, nucleic acids, such things as DNA and RNA. And that's what I have here. Notice it says that they're repetitive combinations of simple subunits. And if you look, let's see if I can focus. This is a very bad copy. But basically, you have this guy up here, and this is your phosphate. Okay, we now know that phosphate is PO4 minus 3. And we know that, you might not know this, but this is your sugar. And nucleic acids is an example of DNA. And you might remember your bio teacher saying that DNA has a sugar phosphate backbone. Once again, just showing that idea that it's these repeating patterns of simple units. Phosphate, that is sugar. Also, technically, that is glucose. Okay, so sugar, phosphate, backbone. And that's all that most of the the things in your body are made out of. You are made up of large molecules such as polymers. You're made up of DNA. You're made up of protein. And they're just very simple subunits. The next thing is students know the bonding characteristics of carbon that result in the formation of a large variety of structures, complex polymers, etc. Basically, this is the same exact idea. Your body, okay, and it's because carbon can bond so well that your body is basically made out of carbon and hydrogen and nitrogen, oxygen, and fluorine, and other molecules, but mainly carbon is the center of that. And the reason is because carbon always wants 4 bonds. Now, another reason carbon is so special, and I just zoomed on over to try and find this guy. Another reason carbon is so special is because of the flying electrons. You know that he can accept 4 electrons and have a negative charge, or get rid of 4 electrons and have a positive charge. And it's because he can easily gain or let them leave that he's able to result in the formation of many, many structures. And it is because he can give and take away his electrons. So moving on to section 11. So section 11, this has to do with nuclear chemistry. And basically there are 3 types of particles. The 3 most types of particles are alpha, beta, and gamma. Now alpha is Greek letter alpha. It looks like this. Beta is Greek letter beta. It looks like this with an extra little line at the end. And gamma is basically kind of half of an 8 with it chopped off at the top. So we are going to divide our paper into 3. 1, 2, 3 down here. And I'm going to talk about alpha particles here, if I can spell it right. Alpha particles, and then beta particles. And then gamma particles. Oh, beta. Give me a point for that. Beta's like this. I'm sorry about that. And gamma is the one I wrote down here. I was ahead of myself. So, alpha particles. There are my colored pens. I was looking for them. Alpha particles are also helium atoms. And the way I remember that alpha particles are helium atoms is that alpha, ha, ha, he, like you're laughing, ha, ha, he. Alpha particles are helium atoms. So a helium atom looks like this. It's 4,2He. And you might see a chemical equation like this. 238 92U gives you 4,2He plus 234TH and 90. So you might have heard of radiation, okay? And this is alpha radiation. Notice uranium is emitting a helium particle. So you're starting with uranium, you're making a helium particle, and you're making a thorium particle. So you're starting with one element and you're ending up with a different element. And just something I want you to pay attention to. Notice 4 plus 234 on top give you 238 over here. And if we look at the bottom, 90 plus 2 gives you 92. Okay? Beta particles are typically written like this, or they are classified as an electron, so as an E negative. And usually their symbol looks something like this, 0, -1E or 0, -1B for beta particles. And their equation, if they're involved in an equation, looks something like this. 23892 uranium, 0, -1E plus 23893 NP. So notice you started with uranium. Okay, you emitted what's known as a beta particle. Either it could be an E here because it's technically an electron, or a B. And you're left with element NP, which I can't think of the name of right now. But this is how one element turns into another element, is by emitting particles. Either they emit helium particles, that's alpha radiation, or they emit beta particles, that is would be basically an electron. And what you need to pay attention to here, what's important, is notice the top on one side, 0 plus 238 equals 238 on the other side, and then on the bottom, notice -1 and 93 give you 92, and that's what it is on the bottom here. Okay? And then we've got gamma radiation, last but not least. So gamma radiation typically looks like this in an equation. You'll see it tomorrow when we go over the worksheet. And I'm just going to say that these are high energy. Now, all three of these are sources of radiation. So think about when, I think it's called the Fukushima nuclear plant in Japan, when that got destabilized because of the earthquake and the tsunami. It emitted gamma radiation, which is very harmful. Now, there's alpha radiation all around us, not so much beta, and then gamma's the really bad stuff. So we need to figure out how to protect ourselves. And so I'm going to write how to protect myself, and I'm going to write it all across, how to protect myself, and then across again, how to protect ECT myself. Now, as the alphabet increases, A, B, G, the radiation gets stronger, okay, and it can harm you more. So for alpha radiation, to protect yourself, all you would need is a piece of paper. Hold on, Mr. Greer's knocking at the door. I'll be there in a minute. And I'm back, even though you couldn't really tell. So anyways, alpha radiation, it's lowest in the alphabet. How to protect yourself? All you'd have to do is hold up a sheet of paper. So I'm just going to say sheet of paper. So if somebody was blasting alpha radiation at you and you wanted to protect yourself, all you'd have to do is hold up a thin piece of paper and you would be protected. Those alpha rays, the alpha radiation couldn't get past you. Now, beta particles, a little higher up in the alphabet, you need a little bit more to help you out with this. And how you'd protect yourself is by holding up maybe a thin piece of foil. So I'm going to do my best to draw a really pretty foil here. I'm going to say aluminum foil. I promise that says foil. Aluminum foil. That's all you'd have to do to protect yourself against a beta particle. If somebody is blasting beta radiation at you, beta particles, a piece of paper is only going to protect you against alpha rays, alpha radiation. So you would have to protect yourself using something stronger like aluminum foil. Now, gamma radiation, like what is released from nuclear power plants, if the radiation gets out, it is higher in the alphabet, known as G, and you need something much stronger. So something pretty similar to gamma radiation is X-rays. And at an X-ray place, they put that lead bib on you. That's my best drawing of a lead bib. Okay, so you need something very thick, a lead bib, or a very, very, very thick concrete wall. I'm going to say thick concrete wall. Okay, gamma rays, gamma radiation is very, very strong. So in order to protect yourself, you need something like a lead bib, like you would if you had an X-ray, or you need a very, very, very thick concrete wall in order to protect yourself. So you know what? If your periods 1, 3, and 5, we're going to learn about this more tomorrow. If periods 4 or 6, don't worry about it. Just try and remember that carbon is the center of all life, known as basic subunits. And then there are 3 types of radiation, alpha, beta, and gamma. Gamma is the strongest. How to protect yourself, make sure you learn that. And then just knowing these weird equations, the top on one side equals the top on the other. The bottom on one side equals the bottom of the other. Okay? So I hope you guys have a great night, and I'll see you guys tomorrow, hopefully.